Are you mad today, Grace? Grace? Are you? So we're going to talk about scientific notation. I'm going to get lazy here, so if you see me, just use SN, and that's what it means. So instead of writing that big old thing out all the time, we could write SN. So, what is this? This is just a way or a form to write really big numbers or really small numbers in kind of an easier form. Now, again, I don't really like what they do in this book because some of the numbers that they use or try to do scientific notation to me, it's a lot easier if they would just use the number. Okay, so, but you would use scientific notation if you were working with like atoms a lot or trying to build like a rocket ship, like a legitimate rocket ship for NASA. Because they would have some kind of calculations that would be really big. So, for instance, don't say it out loud. What's my number? Everybody got an answer?
Mm-hmm.
How much?
37 trillion.
Trillion? Everybody agree? Okay? And then, obviously, we could have a really small number. And anytime that we talk about really small numbers, we're talking about decimals. Okay? So when you talk about decimal places, I found out that we're not very good as a whole with rounding. I never thought rounding, the concept, was very hard until I got here. Apparently it's astronomically hard. Okay? Whatever. Anyway, so this right here, what is this spot called in decimals? The tenths, right? And then what?
Hundreds, 10 hundredths,
Thousands. Then what?
10,000,
10,000s,
100,000,
100,000s, and millions, right? How we say that, we always put a little TH on the end, okay? But if we're going to round to a decimal place, we always look at one more place, right? Then if it's 5 or higher, we round up, and if it's under 5, we just leave it alone. I don't know why that concept's very hard, but it really is for our older high school kids. Okay? So, we're going to try to, instead of writing 37 trillion, we're going to have a way to write that in a little condensed form. Okay? So, what is scientific notation? It is, you're going to have a decimal part, and this decimal part has to be a number between 0 and 10. Okay? Which includes all non-zero numbers. So first off, does that make sense? So I'm going to have a number part. So it's going to be some number part. But this number part has to be some number between 0 and 10. So it's going to be a decimal part. Okay? It's got to be bigger than 0. But less than 10. And now you got to sit in that all the rest of the day. Okay? All right? Does that make sense to everybody? So we're including all non-zero numbers in our problem. So if we went back to our problem on the board, our number part would be what? What would we take 37 trillion and make our number part? We would just make it 3.7, right? It's got to be a number between 0 and 10. So, how we do this, you're going to move your decimal point to make your new number. And that new number or decimal always has to be between 0 and 10. Okay? The next part, it's always going to be a product. So, you're always going to have a multiplication sign in whatever problem that you do. So if you wanted to use the dot, you can use the dot. Most of the time, again, they go back to the little x. And then you're going to have an exponent part. And the exponent part is always going to have a base. What does the base of an exponent mean?
The number that you're like taking the exponent.
So it's like the big part, right? Okay? So you're always going to have a base of 10. So when you have this, you have the number part, the product, and then some exponent with the base of 10. Why would you say we would use a base of 10?
It's like every time you multiply with the number that has a 0, you like move it to the right. If it's positive.
Perfect. We use a base of 10 because if we multiply or divide by 10, we move the decimal one place, one way or the other. Okay? So then we have a base of 10. Our exponent is positive for really big numbers. Our exponent is negative for really small numbers or decimals. And how do you think we figure this out? How do you think we figure out what our number actually is? Well, again, if we take into consideration 37 trillion, right? How do you think we figure out what our exponent's going to be for 37 trillion? If we're going to have, for a really big number, we're going to have a positive exponent. How do we figure out what that number is that the exponent's going to be?
Like how many zeros or like how many more numbers in each.
Perfect.
Gets the number.
Okay, so to figure out what your exponent is, you're going to count the number of places the decimal moves. So that's why I would always start out by finding this number part. So I'm going to look at all the numbers that are in, I'm looking for the non-zero numbers, and I'm going to make a number between 0 and 10. So that's how I looked at my original problem. I had 37, so I put 3.7 because that's between 0 and 10. And now I'm going to count the number of places that the decimal moved. So where did it start out? It starts out right there, right? Where does it end up? It ends up right there. So how many places did I move?
13.
13. So that becomes my exponent. So again, just think 3, 6, 9, 12, and then one more for 13, right? Instead of, no offense to Grace, so she's trying to count them all out, right? That gets a little confusing because then you forget what zero you're on and you got to start all over again, right? It's a little easier when it's on your piece of paper and you can look at it.
You never get rid of that.
It's been that way for a long time.
No, your old one used to be the purge. The siren thing.
Well, that's my alarm.
Oh.
It's still on. All right. So if we go back to the other one that we were looking at, up on the board. I don't know if I have enough. Then we have this, right? So, let's try this one out. Decimal part. What number can I form that would be between 0 and 10? Using all non-zero numbers.
0.8.
Is 0.8 in between 0 and 10?
8.
Okay, so you caught me. We better say between 1 and 10. So erase the 0 and say 1 and 10.
8.
Okay? So my number would be what?
8.
8. Okay, so we would come back here. We'd say 8.0 or just 8. That doesn't matter. Times. We're always going to have 10. Now, how many places did we move it? To go from where it started to where it ended up. So here where it started is obvious because there's already a decimal to that spot right there. How many spots do we have? 13. But what did I tell you it should be?
Negative 13.
It should be negative exponent. Okay? So, that makes sense? All right. Going the wrong way first, but no big deal. All right, let's try it out. Any questions with the words? So, here's my problem. The first thing I want you to do again is I want you to think about how you would say this number. Because again, I don't think we're very good at that. So think about what that number is first and then convert it into scientific notation. So if we're converting it into scientific notation, which is these three parts, what do I call this kind of number? In the book, they would call this just standard form. So if you hear or see standard form somewhere, it just means numbers that you would normally think about. So take this and rewrite it into scientific notation. See what you get. So, first off, everybody got an answer?
Yep.
First off, how would you say this number?
2 trillion 500 billion.
2,500 billion, or sometimes they would just say 2.5 trillion, right?
That's billion. Who said trillion?
Jacob.
We
Jacob.
Carson both said it. Me and Carson both said it.
Carson, come on. All right.
Yeah.
Two what?
Billion.
2,500,000 or 500 million. So we would still say 2.5 billion dollars, right? Somebody, there are billionaires. Do we have a trillionaire? I don't think so either. Okay. So before we go on to that, look up here. Remember when I asked you what the other words were? Here's the words, right? So we're used to billions, trillions. Now look at the other words. Quadrillion, quintillion, sextillion, septillion, octillion. Right? So those are all words that actually are numbers. But notice, look. Look what's the next column.
Checks. For like each.
What? Checks. No,
Like
right here.
checks.
This is the next column.
Yeah.
What do those mean? What those mean are exactly what we're talking about right here. Okay, so if we went down to octillion, it says 10 to the 27th place, right? 10 to the 27th place means that's how many zeros we would have. So we would actually have 27 zeros at the end of that number. And then it would be an octillion number. That make sense? Pretty cool, right? All right, so back to what we were talking about. So what is my decimal part? What'd you come up with for the decimal part?
2.5.
2.5, okay? It's always got to be times. It's always got to have a base of 10. And how many places did we move?
9.
9 places. How do we do?
Good. So then that would be your answer.
This is my answer. So if they tell me to take standard form and write it as scientific notation, that's my answer. Piece of cake, right?
Yes, sir.
All right, let's go back and look at another, go in the other direction. Wrong class. So here's my next one. Now, before you start this one, just be careful, or you don't have to be careful, but the book's probably going to put a 0 out there too. That 0 out there doesn't matter anything. Okay? We just start and move it from this to wherever we're going to go. So, try it again. Try to take, so this would still be considered standard form because it's written as a decimal, just like our big number. So write this into scientific notation. But again, same rules. Everybody got an answer? So, decimal part. What would we say? 5.4, right? It's got to be between 1 and 10, times 10.
To the negative. To the
1,
negative.
2, 3, 4, 5. Perfect. To the negative 5th. Any questions? Piece of cake, right? How do I say this number right here? This one right here. That's it, right? So, how about this? I want you to think about the decimal part of this problem right here, or this number right here. So what would you write for the decimal part of your number? So again, we're converting the standard form into scientific notation, but I want to know what you would use for your number part, or the decimal part, the very first chunk. Jacob, what would you say?
9.65,832.
Jacob, that's not between.
Yeah, 9 point.
You said 9 points.
Okay, he's right. He's right. You just don't have to say it how you said it. So, what's your number? Don't try to use the thousands and stuff. Just tell me the number with your decimal point. Say what you said.
9.65.
No, don't say
Oh,
65.
65.
65832, right? So I'm going to list all of them. All of the non-zero numbers has to be a part of my decimal part. Make sense? Times 10 to the what again? Remember, I got to go where my decimal ended up from where it began. So how many total places did I move to? How many? 11. Is that right? 3, 6, 9, 10, 11. Everybody agree? So the most important part of this is what Jacob was stumbling through here. Okay? You don't have to say 65,832 after that, because these are all decimal places now. Okay? The other one that's kind of confusing is a number like this. If we had and we want to write this one in scientific notation. So we want to include all non-zero numbers. Include all non-zero numbers. But what's the kind of conundrum in this problem? There's a 0 in between the non-zero numbers, right? So if this ever happens, you still have to include all the non-zero numbers, you're gonna include a 0 that's in between there. So this one would be written as 1.057 and then times 10 to the what? 369. Exactly right. But again, I wanted to show you something like this because, yes, we don't ever want any zeros in the decimal part, but if it's included in between other numbers, then we're going to do it. That makes sense to everybody? Okay? Questions there? So we went from standard form to scientific notation. All right, so it makes sense that we can go the other way. So the next ones are going to turn scientific notation into standard form. These to me are a little bit more simple because they basically give you the answer. So we start out nice and simple. We have to have scientific notation. Okay? So my kind of process here is, number one, I'm going to write down decimal part down. Whatever they give me as the decimal part, I'm going to write down. And I really don't even care if you include the decimal or not. That doesn't matter. So in this particular case, if it's something 0.0, you don't have to write that part if that's confusing to you. All right? But in all of these other cases, you would have had to write all of those numbers down. Okay? And then, number 2, I'm going to move the decimal the exponent number of times. So whatever the exponent tells me, that's how I'm going to move it, or where I'm going to move it. So if it's a positive exponent, I'm going to move my decimal to the right. Because if it's a positive exponent, my number is going to end up being a big number. So if it's a negative exponent, we're going to move it to the left, right? And again, anytime that I have a negative exponent in scientific notation, it tells me that I should end up with a decimal number. So, from here now, how many places am I going to move it? I'm going to move it the exponent number of times. So I'm going to move my decimal 6 places to the right because it's a positive. So here's 1, and then I'm just going to start filling in zeros. So 1, 2, 3, 4, 5, 6. Essentially, if there's only one number in my decimal part, this number tells me how many zeros should be in my answer. That makes sense? Now, if there's multiple numbers in my decimal part, like this one over here, I have to include all of those as a part of my 11. Okay? But in this case, then, we're going to erase our decimal point, because now it is right here, because we moved it 6 places. And then the last thing is, big star here. Don't forget what? Yes. In your big numbers. And ladies and gentlemen, there are never commas in decimals. Some people try to put them in there. There's not, okay? So, do I need decimals in this? Or sorry, do I need commas in this answer? Yes. So again, how do I figure out where my commas go?
Every 3 numbers.
Always start at my decimal though, right? And then count every 3 numbers. So this number is what?
6 million.
How much? How about 2 million?
6 million?
Oh,
I just did an
I tell you what, you 3.
I just did an
I'm pretty sure you 3 three are brothers.
This is the first time I've
You,
done this.
you, and you. Yeah.
No,
Ours has done it too, you didn't see.
those two are brothers. I am the guy who just lives on the
I think
hill.
it hangs around them too.
You're adopted.
Those two are brothers. Nathan's team. I think it's because of the teacher.
Nathan's adopted.
You think it's the teacher's fault?
Yeah.
Oh,
Well, the rest of us are crazy.
yeah.
Well, Grace, sometimes you ask, like, when you bleed, do you bleed?
I do not.
All right, try this one. So write this in standard form now. So again, scientific notation to standard form. Oh wait, sorry, I forgot a number. 4. 1.74. Makes a big difference though, doesn't it? So again, make sure you count how many places you're going to move. Fill in your zeros. And then don't forget to go back and put commas in. So, put down your decimal number. If you want to put the decimal in there, that's fine, just to show yourself where it is. Otherwise, now I'm going to move it 7 places to the what direction?
Right.
Right, because it's positive, right? So 1, 2. So I got to count those 2 numbers. And then 5 more zeros. So now I come back and I put my commas back in. And what number do I have now?
17. What?
It's not 1 million! Oh, well, yeah. Yeah. 17,400,000. Jeepers, do we gotta send you back to like, when did we learn big numbers? 4th grade? Blame it on the computer. Wham. Alright. Anybody besides Alex have a problem with numbers? Alright, let's try to go the other way. So, 2.37 times 10 to the negative 5th. So, exact same thing that we're going to do, but now I have to keep my decimal point, and I'm not going to have commas. But now I'm going to move it which way? Because it's negative.
Left.
To the left. All right, to the left. So basically, I'm asking you how many zeros are between the decimal point and the 2, essentially, right? Now, when you go this way, it doesn't matter how many numbers are in your decimal part, does it? You're only going to move it one place over that first whole number, and then the rest of them should all be zeros. So really, I should always know how many zeros I should have at the beginning of the problem, right? Because I'm always going to move it 1, and I'm subtracting 1 from that number, so I should have how many zeros in this problem? 4, right? So, we'll finish this up tomorrow, and you can work on your assignment in class.
Wait,